So we're here to solve this challenging killer Sudoku puzzle by Michael Rios. You'll actually see the Sudoku part as Su-do-ku. This is a variation that has two negative symbols, two negative values actually in each row, each column, each box. That's going to be a really tough constraint to work with. And this is also a puzzle which will be a little tougher to use in PenPy than normal, in part because of those negative values you've got to be putting in. Something I did for myself, I turned on surface and number large, number small. I'm going to use number small for my candidates or notes, large for the real values. With large, I can put in a negative symbol. I can't do that on number normal. And surface can let me shade some cells. And I think where I want to start with this puzzle is to just start to do some notation to help me know where there are positive values. And I'll always have those in green. So a cell in green is going to be a for sure positive digit. I'm going to mark some cages. Let's maybe pick a color like blue. These cages will somewhere have at least one negative cell. Right now I don't know more than that, but my guess is knowing cells that may be negative will be useful. You'll see that cages like this 5 and 3 cells, normally 1 plus 2 plus 3 equals 6 is a minimum there. So this is below that minimum. 1 plus 2 plus 3 plus 4 is 10. This is below that minimum. 2 is below the minimum. I think those look to be the forced negatives, and there's some more forced positives. 10 in 2 cells, 15 in 2 cells, 17 in 3 cells, 9 and 8 is 17, and plus 0, like 16 would be the largest value that a 3-cell cage could be that would include a negative value. 9 plus 8 minus 1 is 16, so this is green, this is green. 21 for sure is green for that thinking. 27, 9 plus 8 plus 7, and 3 is 24, so it always has to have plus 3. It always has to have 4 positive digits. I think these are all the ones that stand out to me at the start as being forced positives. One thing that's interesting, having placed those in the grid, is actually seeing in this bottom box we've put colors everywhere. There's nowhere else we've done that, but one thing that means is we actually have the 2 negative cells are both going to be in the 6th column here. Maybe both in the 1 cage, maybe 1 in the 0 cage and 1 in the 1 cage, but these cells will be positive. And we're effectively using Sudoku-like logic to color in other cells as positive or negative and seeing if that takes us somewhere. There are 2 things I use to break into the puzzle, and I'll try to talk through them sort of directly back to back. They're both observations that still stem from some of the stuff in the bottom box. And one of the observations is 21 is a pretty large sum. And so I can't believe I get too many more into this remaining space. And a normal way to think about this is that the sum from 1 to 9 is 45. And I've already used 21 in the left. And the minimum I could use on the right is 6. And how that would look is however these values are, say 1, 2, 3 were in them. That means 27 digits, 27 out of 45 have been accounted for already on the left and right in this minimum example. And it leaves just 18 for these cells in this middle. 18 getting up to a total sum of 27 is a forced sum of 9 there and 18 in these cells. And so it turns out for sure, if you look at min-max sum requirements, this 21, which is very large, next to a 27, which is very large, forces a 9 up top. So we get to a total potential value as well as a 1, 2, 3 in this column. And we don't know which of these are negative values, but the smallest values have to be here. And we get to where we have a 9 somewhere in those cells, a 9 up in these cells. This 1, 2, 3 gives us a 4, 5 up top. And there's more we can actually do now. I'll come back to this in a second. Actually, I'll just mark in right now 6, 7, 8 and not think more about it. There's actually something we can really interestingly do with this 1 cage. But there's something else in this puzzle which is maybe a global constraint that's drawing your attention. The start is tied to the theme, which is this plus. The center row and center column are forming most of a plus shape except for that center cell. And you can ask yourself first, does that have to be positive or negative? It should stand out pretty quickly. It's got to be a negative value. And one reason is that the value of the whole row right now, including at least 1 negative digit somewhere in this row, is 39 out of 45. And if you had, if you had 2 negative values, like a -1 and a -2, you're going to have a delta of 2 times 1 and 2 times 2. Essentially taking a +1 to a -1 is having an effect of 2 times 1 on the total sum getting up to 45 for the row. And I guess a way to try to mark that, let's just sort of mark like -x, -y, and let's make this z. And let's say that if we had the normal value for the whole row being 45, right now we have the case of 16 plus 25 plus z being 45, and I'll just, for clarity, I'll just say it's the absolute value of Z. It doesn't matter if it's negative or positive. This set of digits that get us to there work like this, but we have minus x and minus y going on. And so what's the effect of minus x? What it actually means is that we don't have a clean sum of 39. We have a sum of that has had x go from a plus x to a minus x. We've subtracted 2x from the normal value of 45 in the row, and we've subtracted 2 times the normal value of y from this row. And already with these values, there's no way to fulfill this equation. So let's just simplify this somewhat to say that 39 plus 2x plus z is what is going to be working here. And we actually know for sure that we're just dealing with a negative in the center and another value. And this is still the thing to think about, is what are the values that make this work out? And x can't be large, and that's because if we subtract 3 from a row that normally adds up to 45, we now effectively have the whole value, 39 plus 2x is 45, z has to be 0 in the center. There's no value that's a subtracted value in these white cells that gets us all the way to this full sum. We have to have a value that's either 1 or 2. And there are 2 ways to think about this. If x is 2, then z is 2. That's not going to work. If x is 1, z is 4, and that's a perfect solution. And you could have looked at this through the columns. In the columns, the way this goes is something like 10 plus 27, which is 37. And that's going to be some other value plus, again, whatever is that center digit. It doesn't matter if it's positive or negative strictly. It is actually a negative value, but the way it comes up to a total sum of 45, we'll just treat it like its normal value, so you don't have to do anything special. And here again, we have a few choices. Y can be 1 or 2 or 3. If y is 1, z is 6, that's okay. If y is 2, z is 4, that's okay. If y is 3, z is 2, that's okay. And so the column isn't as constrained as the row, in part because the row is much closer to the sum of 45. I'm not sure if that was a full way to follow it, but somewhere between algebra class and Sudoku, there's a way to show that the center cell of this puzzle is a -4. Somewhere in this row is a -1, and somewhere in the center column is a -2. And this, as a -4, is another cell you could place at the start of the puzzle if you don't get this break-in with a 9 instead. But these were the 2 first digits I got when I solved it a little while ago in paper, and they're the first 2 digits I'm getting today as I'm going through this. Let's now come back though to this one cage, and particularly after we've now marked enough in the grid to get all the way to this 9, 4, 5 set, giving us a 6, 7, 8 set. 6, 7, and 8 are pretty large positive values, and we are subtracting 1 or 2 very small values. It actually should be clear to you right now it's got to be 2 values being subtracted, and the largest thing we can subtract is 2 and 3, which is -5, which means the smallest positive here, 6. 6 minus 2 minus 3 is absolutely the only way we get this to work out. So we can clarify those values. We can put in this is a 1 and also that it's a positive cell. And if we mark in some other numbers as candidates here, we actually have at the start of the grid, this is 7 and 9. Right now we could say this 15 is 7 and 8. What we'll see is we already have the 7 in this 4th row. And so the 7 is here, the 8 is here. We've got some good progress coming through from doing that. We actually can mark some candidates into this lower space, the 4. That's not yet in this box because it's in the center cell, has to come from there. So 9, 4, 8 are over here, 5, 6, 7 are here. This whole column now is 1, 2, 3, 8 with a -2. 1, 3, and 8 are 12, and -2 gets us to 10, so that all looks reasonable. The 8 has to be in the top box. 6 and 7 are coming in somewhere over there. We have, in this row, some constraints now, like a 9 is over in the space, and actually an 8 is over in the space. And remember when we did our math, we said that a -1 is in this whole row, so all of the sums break apart. And what's actually interesting about that is if I put 6 over on the right, 7 and 9 and 6 come up to 22, and I need to put in a +1 to get to 23. But I can't get to 23 with a +1 because this row has a -1, and so the 6 is over here. This is now going to be -1. On top of that gives us 13 plus 3. So the full set for that space are these numbers, and the full set over here, all positive, are 9, 5, and 2. So we'll mark those in, see if that gives us some more help. And I think we'll have to sort of keep working from there. One thing to think about in particular, where this 10kh at the top has just one negative value in it, this value to the left, or this kh to the left, has at least one negative in it. Notice that it can't have two negatives right now, because if both of these were negative, again, you could have like a 1 with a 6 here, but we're always subtracting a minimum of 7 away from this, and -7 has no digits going to get all the way up to +7. And so one of these is negative, one of these three is negative, but that means this cell is positive because there's only one more negative in this cage. And we said that 2 is the value that's not negative, and 2 is the negative value up here. So this is a 1, 3, this is 1, 3. We now actually have a 2, 5 pair in those remaining cells, and we can think about which are the positive or negative values. And there's a few things to think through, and one which I think is a novel kind of constraint for this puzzle, but a pretty interesting one, is to recognize that when you have just 2 cells left over in a sum, already being at the cage's sum is an issue. So let's imagine 7 were in this cage and were positive. If 7 is positive in that cage, we have 2 cells remaining who add up to 0, and that would have to be an x and a -x, and you can't repeat a digit in a cage. And so 7 is a dangerous number to be in a cage that already is 7. And the only way that could work is if it's -7. If it's -7, we have to have the remaining digits get up to 14. And the only way to get to 14 would be 5 with 9, if the largest value here can be 5, but 9 is already accounted for in this cage. So 7 cannot be negative in the 7 sum, and 7 can't be a positive value in a 7 sum, because 7 plus 2 remaining digits that are 0 in aggregate to get to 7, we would have x and -x, and that's no good. So I think the tricky deduction, but again a summation-based deduction, is that the 7 is up top. We're actually going to for sure, I think, have that the 6 is positive. Let's see why that is. Whichever this value of 1 or 3 is the other number that's in this cage. So 6 with 1 or 3 is what's up top. The other values are 2 and 5. Let's think about if the 2 or 5 can be negative. 6 plus, knowing one of these is negative already, this is never larger than 3. It could be 5, 6 minus 1 or 6 minus 3. So this is always positive. And once this is positive, 5 plus 6, 11 is too large, but 2 plus 6, 8 minus 1 would be fine. And so this looks to be 6 and 1 and a big 2, and this 5, and that means this is the 1, this is the 3. Remember, the negative value in this middle row is -1, so this cell that contains the 3 is positive, and this 5 I marked for 2 reasons must be negative. The first is, again, if it's positive, we have 0 left over for the remaining 2 cells to add together to, and there's no values that are going to make that work. So we've marked that in. Notice we actually have a case like before where the 2 negatives in this 4th row are just in the top part of this box. So this cell here is positive. That makes this cell here negative. Let's see if there's some more we can do through the constraints in the grid to make some headway at this moment. One thing that may be useful for us is to start to consider, maybe we can start working from this 14, but some remaining values in these spaces. My guess is we're going to be pretty constrained with the large digits with what else is left in these rows or columns. For instance, this 6th row now is 1, 2, 3, 4 left, and then that actually looks like one thing we can start from. If this is actually over on this side, this is strictly 2, 3, 4, 2, 3, 4, 2, 3, 4. And this for sure is actually the 1. It's the only place left for it in the row because there's a 1 in one of these 3 cells. That makes this a -3. It's just a -2. makes this a -3. That's actually looks to be some helpful progress. And I'm going to actually work off that for a bit. And how I'm going to work off that is taking that I just found 2 negative cells and clearing out that row. If this is -5 and we're subtracting a 2 or a 3 or a 4, that could actually get, -5 plus 9 is a total of 4. This has to be positive to get this whole value to work, and that's going to be pretty constraining. It means we're going to have a negative value here, and my guess is with a negative plus a positive plus a thing that gets up to 10, this is going to have to be a pretty big cell. Actually, the most that this cage -2 plus 4 is 2. The most that cage can give is that, and if that's 2, that means 8 or 9 is the value here. Let's come back though over to this corner, which we started with. We have 2 digits that add up to 7 in 2 cells, and 2 and 3 are already in that row, so the normal 2, 5, and 3, 4 pairs are gone. So this is a 1, 6 pair. And with a 1, 6 pair marked, I'm guessing this 10 now is constrained. 1, 9 is gone, 3, 7 is gone, 4, 6 is gone. This is 2, 8 coming up. We have 4 digits left here, and here's another case where we can do some fun algebra constraints to understand what pairs come down here. This 0 is going to have 1 negative and 2 positive values to work out, and the 2 values in these cells have to be 1 apart because the partial sum already in the cage is a 1, and that means we're going to need to have an even and odd number. The only set that are 2 apart would have 4, 5 there. 7, 9 come up above, and separate out these spaces. Can mark in those notes. The 5 will be negative, the 4 will be positive, and these 2 values here will be positive. We're still trying to work our way, though, really into the results on the side, and maybe this is where, let's see what more we can do. There's another value we haven't placed, which is this last one in the cell, and that's probably what's going to do it. This is a 5. It's the last value in the box. Everything else has been notated. That makes this a 9. And now we come back, what I said before, the cell here being pretty limited. 8's the only value left for it. So we need to have these values be -2 and +4. So 2, 4 in some order. This becomes a 3 for sure. 3 minus 5 is still -2. So this is a 7. That now makes this the 5, 6, 7, clearing out the space. This top one is a 9, 4. This is also a 9, 4. Putting in that 7 below makes a 9, 7 come in. And putting in that 7 now actually by Sudoku gives us a 7 in the cell. And 7 in a 3 cage is going to need if it were -7, be with 10. If it's a +7, it's with -4. And the only one that makes sense, because we don't have -10s in this puzzle, is this. That now -4 is going to make the 4 come here, and the 2 here, which will again be the negative value. So this is -2, this is +4. This whole column is now just positive numbers. That means that the 1 isn't in the cell, because again the 1 is a negative value in this cage, and an 8 is in that cell because, as we said at the start, 8's down below, and 8 removed and 1 removed, because this is a positive value, means 6 goes in there. Down here, completing the column, we have a 1 and 3 to place, and we can use the values we already have to clarify those. We're going to get a 6 down into this bottom spot just because of the 6 here and the 6 there. So let's figure out if we have a 6 in one of these cells. If that 6 is negative, we're at -2. Coming up to a sum of 8, we need a 10. That's no good, so the 6 is positive. That means it's 1 + 3 + 6, which is 10 - 2, so a 2 is in the space. So over here, the 2 has to be up above, the 8 down below. That makes this a 9, makes this an 8, makes this a 4, makes this a 9. This is just 1, 8. This is 4 with 5. think that's all we can do right now. We're going to have to come back over to this side some. And I think there are a few ways to go about that. Let's start by just marking the canons we know. We've got 3, 4, 6, 3, 4, 6, and 4, 6. Coming across potentially both digits being negative and the 0. It actually looks like I haven't taken into account one observation. Notice that the 7 in the bottom box is in columns 7 or 8. The 7 in the middle center box on the right side, sorry, the right center box is also in columns 7 and 8. So the 7 up here has to be in the far right, and there are already 2 7s in rows 1 and 2, so the 7 is right here. And now we have a space where we've got to figure out how do we get a total value of 0. 7 is going to be either the large digit or the only negative digit, and 3 and 4 look to be the remaining ones. There's no use with 6, it's going to get us somewhere. So this is 7, 4, 3, and now we have to think about where is a negative versus a positive. If 7 is negative, both of these are positive, and there aren't 3 negatives in this. There aren't 2 negatives in this box. So the 7 is positive, the 3, 4 are both negative, which we'll come back and put in here. And that 6 is positive. That now means this is 14, and a -2 will give the right next things there. We'll do some Sudoku coming up and down the grid. Got this 2. Let's come back to do some coloring. Got red, got green. These are green. I think that's all I've got right now, just from the coloring angle. One thing that looks pretty promising to come back to is this upper right corner. Now that both of these are positive, for sure a 6 is in one of these cells, and then it could be a 5 or a 9. And we mentioned maybe 5-10 minutes ago how in this cage, having a positive 7 with 2 values left that would both, essentially the delta being 0 would be an issue. Look right now, if this is 6 with 5, we've got 2 digits that add up to 11 and 2 remaining digits that add up to 0, and x minus x isn't possible here. So where 6 is up top, you cannot put a 5 next to that 6. Like a 5 is actually nowhere in that cage. At least if it's positive, I should be careful. Like you could have a -5, that would be fine, but there's not a positive 5 here. So this is 6 and 9. And we actually know for sure that the 5 is there, the 9 is here. That gives 9, 7, 7, 8, and those digits we can fill in. We also now know that we need to have one more negative up top, which means this is going to be positive value there, which means this is a 3, 8. Because again, -2 is the value that's somewhere in the space, and the actual -2 can't be in the bottom because the 2 is already there. So the space that the 2 goes is right here, and it's negative. We know that's positive. These cells are positive. That a negative is in this 2 cage means that this is not, this cell on the 7 couldn't also be negative. So the cell that is negative in the 7 is this one. And that will now also clarify that we've got a 6 and a -1. And we have positives in these cells, and a negative in these cells, and a negative in these cells. So we're still going to need to now do some math to get the last values here, but we're getting pretty close with the digits we put in. Notice with 2 2s, we've just now added this one up top as a 2, 8 pair. So it sums to a total of 17. The 2 and 7 gives us 9, and 8 more gives us that value. So 3 is up top, 8 is down below. There's an 8 to place in this upper right corner, and it's got to be in the 2nd row and also in the 8th column based on other 8s in the grid. We have, in this top box, we have a 1 that's going to be going somewhere in these cells, and for sure it actually has to be right here. We now have 15 plus 1, 16. The only way this is going to get to 11 is to have the single negative value be larger than 1. 1 is too small to be the negative value, the sole negative value in the cell. And whereas having it be cautious, like there could be a -5 in this cage, it actually looks like we just found it is exactly a -5 in the cage, which puts a -5 down here. Well, again, I don't strictly need to do this coloring anymore, but just to make the final solution look good, we'll keep marking it in. This is a 4. This is a 3. This is the last space for a 4. This is the 5. This is a 9. Puts down a 9. Puts a 6. We have a 1, 3 coming over here, and the 3 is the positive, and the 1 is the negative. Puts in a 1. Puts in an 8. Remember, the 1 was negative. We have that 8 giving us 8 with 2. Gives us 2 with 6, and remember the 2 is negative. So the last negative is going to be in this cell up top, and it's a -5, and this is 6. And actually, I don't need that to be, sorry, we already have the negatives. The last negative is this cell down here, it's -4. Sorry, I should have done this by coloring, not jumping over. So to do this for sure, that's negative, so we need 2 negatives down here, and these are there. So fairly tricky solve. Set of steps that were key at the start included doing some coloring in this bottom box, seeing that we had a forced summation constraint that put a 9 in the grid, seeing we could do some algebra with the center cell to get a -4, seeing that we could start to then annotate all of these columns, get examples where we had a 6 with 2 negative values, a 7 in the center box, start to force a -1 to the left, which meant we had these pairs to the right. That gradually got us out through the grid in different ways. Some of the key things look to eventually be actually looking in this first column. We got 7s by Sudoku to give us a -4, that gave us a -2, so I worked through the grid like that. So a lot of interesting places that arithmetic constraints worked alongside the rest of this Sudoku puzzle. Hopefully the talk through of these hard steps to get through the grid were useful for you to understand some of the logic behind this really incredible variation by Michael Rios, and we'll see if we ever post a puzzle like this again soon. But for now, hope you enjoyed the solve and a little bit of this killer Sudoku puzzle. Bye.